Obviously, Unit 3, Lesson 1 through 3, reteach. 4 examples. The first type of problem that we're going to do is factoring using greatest common factor. If I take a look, I can identify this because I have 2 terms. They don't match the red format. Okay? They look more like the GCF format that we've used before. 1, 2 creates 2 lines on the inside with the GCF going out front. The questions you want to ask yourself are, when I'm looking at the numbers, what's the biggest number that divides into both of these? In this case, it's going to be a 2. Some of the problems that we're going to encounter will not have common letters in every single person. If there are 3 terms, then I need to have the letter I'm taking out in every single one of those. In this case, notice I have a Y in the first but not the second, which means it cannot come out front. I can take 2 x's from the first term and 2 x's from the second term, which makes my GCF the 2 and x squared. I then ask myself, 2x squared times what gives me 2x squared y? I need just the y. My signs will match. 2x squared times 4 gives me 8x squared, but I still need another x. Again, I'm thinking about if I remultiply back, do I get what I started with? Factor the trinomial. Whenever we encounter these problems, what we want to do is look at the form, x squared, x, and a number. That's going to fall under the form we've talked about up here. We would set up our parentheses, and we would follow the steps. The letter out front is x and x. Bring down the first sign. A negative times what sign gives me positive 8, and the answer is a positive. What are all the numbers that multiply to give me 8? 1 and 8, 2 and 4. Which one of those activates to 6? 2 and 4. Therefore, I put the 4 first and the 2 second. Special case factoring. You're going to know you have special case because it comes in the form x squared and a number at the end with a subtraction sign. The number at the end has to be a perfect square. You could have a perfect square in front also, which we've done examples of in class. When I see this special case, I'm going to transform it into a trinomial by interjecting or putting in a 0x. We now can factor like x squared, x, and a number. First variable is x and x. They multiply to give me x squared. Bring down the first sign. A negative times what gives me negative 49, and the answer is a minus. In the special case examples, the number at the end will always be made up by a perfect square. 7 and 7 are the answers. They will be the same numbers. Notice, same numbers, opposite signs. Last example is factor completely. Factor completely is over here. It's going to involve us doing GCF first, then focusing on the last part of that problem that we just factored and factoring further. So notice I have 1, 2, 3 terms, looks similar to the top, but it is not a 1x squared. 2, I can take from all 3 of these, but I can take an x and an x. I cannot take an x from the end, so I cannot put an x in my GCF. 2 times what gives me 2x squared? The answer is x squared, and down the minus. 2 times what gives me negative 12, so think of this like triangle piece. The answer is 6x. 2 times what gives me 10, positive 5. As you can see when I do that, what I get in here looks like what I have that I can factor further that we learned about before. It's a trinomial. So I move to my boxes down here, x and x. Bring down the minus. Minus times what gives me positive 5? What two numbers multiply to give me 5? Only 1 and 5. 5 goes first. 1 goes second. They add to 6. Bring down the 2. Don't forget the bring down. And I'm done. If you're watching this video during class, as soon as you're done filling in the notes examples, please put away your iPad and refer to your notes. This is not a time to go on YouTube and look at other videos or listen to music.